Welcome to the deep dive. Today we're taking a bit of a shortcut, really, digging into some critical concepts in modern virtualized IT. We've basically got this distilled wisdom, from an exam prep guide, the 2V0-16.25 certification. And our mission, well, it's to pull out the most important nuggets for you. Those aha moments.
That's right. And while, the source is for an exam, the concepts themselves, they're foundational. Absolutely key to understanding how things like VMware, vSphere, VSN Workspace ONE actually work.
Right.
This isn't just about passing a test. It's really about grasping the core stuff, the mechanics that make today's digital world, well, efficient and resilient.
So maybe you're prepping for a meeting or just trying to get up to speed in the field. Or maybe you're just curious, right?
Yeah.
Get ready.
Yeah.
We're going to unpack these ideas, simplify the jargon, and really show you why this stuff matters. Let's jump in. Okay, so imagine this. You've got these super powerful servers, and on them, tons of virtual machines, right? All needing CPU, needing memory. How do you stop one, maybe some busy database or whatever, from just hogging everything, starving out the others? What's the main tool for that?
That's a classic problem. And the main tool you'd reach for there is a resource limit.
A limit, okay.
Yeah, and the key thing about a limit, especially compared to, say, reservations or shares, is it's absolute. It sets a hard, strict upper boundary.
Right, a boundary on CPU or memory?
Exactly. Think of it like a governor on an engine, that VM. It just cannot go past that defined cap.
Even if the host server has loads more power sitting idle?
Even then. It's a non-negotiable ceiling, a hard stop.
A hard ceiling. Okay, that makes sense for stopping runaways. But, here's a thought. Could setting that limit too tight actually, hurt an application, even if the host could give it more? Is there a risk there?
Oh, absolutely. That's the balancing act, isn't it? Limits are great for guardrails, stopping resource fights. But if you set it too low, too aggressively, you can end up starving a really critical app when it hits an unexpected peak. Like if your VM suddenly needs a burst of CPU, but it hits that limit, it just sits there, capped, can't use the available host power.
So it's a trade-off then?
Yeah.
Control versus potential performance bottlenecks.
Precisely. Which is why you really need to monitor both the VM and the host's overall usage carefully when you use limits.
Got it. That makes perfect sense. Okay, so limits handle individual VMs. But what about groups, like a whole department's apps or maybe a project team? You can't just set 50 individual limits, right? How do you manage resources for a whole bunch of them logically?
Right, and that leads us nicely into resource pools.
Okay.
If limits are like individual speed controls, think of resource pools as creating departmental budgets for your CPU and memory.
Budgets, I like that.
Yeah. A resource pool groups VMs together, logically, and then you allocate a certain amount of CPU and memory funds to that whole group.
So all the VMs in that pool draw from the same pot of resources.
Exactly. All the VMs in, say, the HR department's pool draw from the HR pool's allocation.
And the HR pool can't suddenly spend the marketing pool's budget.
Nope. It stays within its budget, even if other pools have resources left over. It's this really useful layer of abstraction. Lets you map your technical resource controls directly to, business priorities or how your company's structured.
And you can nest them too, right? Pools inside pools.
You can, yeah. It allows for quite complex hierarchies if you need them, mirroring project teams or different service tiers, really flexible without tying everything rigidly to specific physical servers.
Okay, managing resources is one thing, but things go wrong, don't they? Even in perfectly managed pools. So let's talk monitoring and troubleshooting. If you've got a VM acting strangely and you need its whole history, events, tasks, alarms, the works, where's the first place you click in the vSphere client? What's the go-to spot?
For playing detective, you head straight for the Monitor tab.
The Monitor tab, okay.
Yep. Within the vSphere client, select VM, click Monitor. That's your window into everything that VM has been doing over time.
So, performance charts.
Performance charts, yes, but also detailed logs of events, tasks that were run on it, any alarms that were triggered. If a VM suddenly got slow yesterday afternoon, you go there, look at the timeline, see if maybe an update ran or if a specific alarm fired. It gives you that crucial historical context.
That sounds incredibly useful for figuring out what actually happened.
It really is essential for understanding its history and current state.
Okay, let's switch lanes a bit. Network security now.
Yeah.
Imagine you're setting up an intrusion detection system, an IDS, as a VM.
Right.
And this IDS needs to see all the network traffic on its virtual network segment, not just the stuff addressed to its own virtual NIC. How do you configure the virtual switch, the vSphere standard switch or vSwitch, to allow that, to give it that kind of, well, network X-ray vision?
Good question. That requires enabling a specific security policy on the vSwitch port group the IDS VM is connected to. It's called promiscuous mode.
Promiscuous mode. Okay, what does that actually do?
Well, when you enable it, you're basically telling the virtual switch, hey, let any VM connected to this port group see all the network frames passing through you, not just the frames destined for their own MPASI address.
It's just like letting it eavesdrop on the whole conversation on that network segment.
Exactly. It allows it to listen in,
Right.
which is precisely what an IDS or a network sniffer needs to do, right? To analyze packets from other VMs, look for threats, or troubleshoot network issues.
X-ray vision feels about right then. But,
Mhm.
hang on, if a VM can see all the traffic, couldn't that be a pretty big security risk if, the wrong VM got that power?
You've hit the nail on the head. That's the critical insight. Promiscuous mode is incredibly powerful for monitoring and security tools, but you absolutely do not want it enabled carelessly across your network. It creates a potential listening post. If a bad actor compromises a VM that's running in promiscuous mode,
They could potentially grab sensitive data from other VMs on that same network segment.
precisely. So it needs strict control. Only enable it on specific port groups for specific trusted VMs like your IDS, and make sure those VMs are hardened and secured. Use it surgically, not like a blunt instrument.
Right, okay. Use with caution. Got it. Speaking of digging into problems, let's go back to performance, specifically disk I/O. If VM is slow, applications are lagging, users are complaining about storage speed, you suspect a disk I/O latency issue. Where do you look first on the ESXi host itself? Which log file holds the clues?
For disk I/O issues, especially latency, your prime suspect, your first stop on the ESXi host is the vmkernel.log file.
vmkernel.log. Why that one specifically?
Because that's essentially the diary of the ESXi kernel. It logs everything about the core operations, storage device discovery, interactions with storage adapters, driver messages, path failures, latency warnings.
So all the low-level storage stuff.
Exactly. If there's a problem with a specific HBA, a LUN, a path, or just general congestion in the storage fabric affecting that host, chances are you'll find evidence, error messages, or warnings in vmkernel.log.
So checking that log first could save hours of just guessing.
Oh, definitely. Instead of poking around randomly, it points you towards the storage subsystem straight away. Could be physical storage, could be drivers, could be configuration. That log is key.
That's a great tip. I know someone who wasted ages looking elsewhere for an I/O problem once. Knowing vmkernel.log is crucial.
It really is.
Okay, let's pivot. From fixing things to building things robustly. Let's talk storage again, but this time VMware vSAN. How does vSAN make sure your data stays available even if hardware fails, like a host goes offline or a disk drive dies? What's the main policy setting that defines this resilience?
The absolute cornerstone of resilience in vSAN is a storage policy rule called number of failures to tolerate, usually abbreviated as FTT.
FTT, number of failures to tolerate.
Right. This policy rule lets you specify how many simultaneous host, disk, or even network failures a virtual machine's storage object, like its virtual disk, can withstand without becoming unavailable.
So if I said FTT1,
If you set FTT1, vSAN ensures it keeps at least one additional complete copy or replica of your data on different hosts or fault domains within the cluster. That means it can tolerate one failure, one host dying, one disk failing, and your VM keeps running. Its data still accessible.
and FTT2 means it can handle 2 failures.
Exactly. FTT2 provides even more protection by maintaining more replicas or using erasure coding like RAID 6. It's a fundamental part of how vSAN provides high availability and self-healing for storage.
Okay, so higher FTT means more protection, which sounds great for critical apps, but I assume there's a cost. It must use more disk space, right?
Absolutely. That's the trade-off. Each level of FTT you add requires more raw storage capacity to hold those extra data copies or parity information. It also increases the amount of network traffic needed to keep all those copies synchronized. So while FTT2 or FTT3 gives you fantastic resilience, it comes at the cost of capacity and potentially some performance overhead. You need to balance the required protection level against your available resources.
Makes sense. No free lunch, even with resilience. So vSAN handles resilience with FTT.
Yeah.
How does it handle performance, especially in, say, a hybrid setup, where you mix faster flash drives with slower, bigger spinning disks? What's the magic with the flash devices in that scenario?
Oh, the hybrid vSAN architecture. It's quite clever, really. It strategically uses those different types of storage. In a hybrid disk group, the flash devices serve a very specific, critical role. They act as the caching layer.
Caching. For reads or writes or both?
For both, actually. That's key. All incoming write I/O hits the flash cache first. That provides really fast acknowledgement back to the VM, boosting write performance.
Okay.
And for reads, VSN uses that same flash tier as a read cache. Frequently accessed data blocks get promoted to the flash cache, so subsequent reads of that data are super fast.
So the flash is like an express lane speeding everything up.
Pretty much. And then the traditional spinning disks, the magnetic HDDs, they serve as the persistent capacity tier.
Yeah.
They hold the bulk of the data long term. This tiered approach, using flash for speed and spinning disks for capacity, is how hybrid vSAN balances performance and costs so effectively. You get acceleration where it counts most, without needing an all-flash setup, which can be more expensive.
That's a really smart design. Best of both worlds, kind of.
Yeah, it works very well.
Okay, let's zoom out a bit now. Beyond the core server and storage stuff, let's look at the tools that help manage the wider IT world. Because it's not just about infrastructure. It's about users and devices too, right?
Absolutely.
So, huge challenge today, managing this massive mix of devices people use, phones, tablets, laptops, desktops, maybe even weirder stuff like IoT things.
Yeah.
What's the main job of VMware Workspace ONE in trying to tame all that? What's its primary function?
Workspace ONE is fascinating because it aims right at that complexity. Its primary function is really about unifying end-user management, bringing together the management of mobile devices, desktops, rugged devices, other endpoints, all under one umbrella.
Unifying management. So one tool to rule them all.
Kind of, yeah. It's designed to give users a single, secure digital workspace, a place where they can access all their apps, web apps, SaaS apps, native apps, virtual apps, and their data consistently, no matter what device they happen to be using or where they are.
Oh, yeah.
It aims to break down those traditional silos where you managed phones with one system, laptops with another. It's about providing that central, holistic solution.
That sounds ambitious, trying to unify so many different things. Does that complexity shift onto the IT admins trying to manage Workspace ONE itself, or does it genuinely simplify things overall?
It's a fair question. There's definitely an initial setup and integration effort, but the long-term goal, and generally the outcome, is simplification.
How so?
By getting rid of those separate management tools and processes. Instead of juggling multiple systems, you have one console, one set of policies, one way to manage identity and access across everything. So while there's a learning curve, the payoff is usually reduced operational overhead, better security consistency, and importantly, a much smoother experience for the end user.
A smoother user experience is always good. Okay, sticking with making life easier, especially for vSphere admins, managing content. Things like VM templates, ISO files, maybe scripts you reuse all the time. How do you keep that stuff consistent and easy to deploy everywhere, especially across maybe multiple vCenter servers or sites?
Yeah.
What's the big win with using a content library?
Content libraries. They address exactly that problem of consistency and efficiency, particularly in larger setups. A content library is basically a central repository within your vSphere
A
environment.
library for content. Makes sense.
Exactly. You store and manage things like your standard VM templates, your approved operating system, ISO images, OVA, OVF, templates, scripts, that kind of thing.
And the big advantage is
Consistency and efficiency. Big time. Instead of admins having slightly different versions of a template scattered around or manually copying ISOs to different locations,
yeah, I can see that happening.
the content library acts as that single source of truth. You can publish content to it and then subscribe other vCenter servers or clusters to that library.
So if I update the standard Windows Server template in my main library,
That update can automatically sync out to all the subscribed libraries across your different sites or vCenters. Everyone gets the latest approved version. It makes deploying VMs or installing OCs way faster and much more consistent.
wow, okay, that sounds like it would eliminate a ton of headaches and enforce standards.
It absolutely does. It helps with compliance too, ensuring people use the right tested templates. It streamlines patching if you manage OS images centrally. It's just a much cleaner, more efficient way to handle reusable deployment content.
Definitely see the value there. Okay, one last piece then, kind of bringing it all together. The control center for so much of this.
Yeah.
The vCenter Server Appliance, the VCSA.
It's the brain of the operation.
Exactly.
Hmm.
When you're setting up a new VCSA or just connecting to manage things day to day, which specific network port does the main vSphere client UI use? The web interface where you do all the clicking.
Right. Knowing your ports is fundamental for connectivity, firewall, security, all that good stuff.
Yeah.
For the main vSphere client UI, the modern HTML5 one that everyone uses now, it communicates with the VCSA over HTTPS using TCP port 443.
443, the standard HTTPS port.
That's the one. Of course, there are other important ports like 902 for the ESXi host talking back to vCenter, 52480 for the appliance management interface itself, 22 if you needed SSH.
Right.
But for that primary graphical management interface you use constantly, it's port 443.
Good to know. So if you suddenly can't get to your vCenter UI, checking if 443 is open and listening is probably step one.
Definitely a good first check.
Well, whether you're deep in IT studying for something or just, curious about how the digital world works,
Yeah.
hopefully this gives you a clearer picture. Think about the layers of smart engineering, the management, the resilience that's running behind the scenes next time you spin up a VM, use a cloud app, or even just log in remotely. It's pretty intricate stuff.
It really is.
Now that you've got these core ideas under your belt, what part of this whole virtual infrastructure world are you going to dig into next? There's always more to learn. Thanks for joining us on this deep dive.